Welcome on board Maersk Drilling's high-efficiency jackup rig. 4 identical units were delivered to Maersk Drilling from 2008 to 2009 from Keppel FELS in Singapore. In the design of the rigs, special attention was given to increase efficiency and logistics, and to create a safer working environment. The rigs can operate year-round at water depths of up to 350 feet. Join me now as I take you on a guided tour. The high-efficiency jackup rig uses the XY cantilever concept. This entails that the whole cantilever moves as one box, thereby keeping the position of the rotary table in the center of the cantilever at all times. This first well pattern shows a drilling envelope of 45 times 30 feet, which is the typical reach of a conventional 116C type jackup. With the XY cantilever, the Maersk Drilling high-efficiency rigs can reach wells within an envelope of 70 times 44 feet. With the XY cantilever, the combined drilling load remains the same in the full transverse cantilever envelope. The rigs have a combined drilling load of 1,200 tons from 0 to 50 feet cantilever reach, and from 50 to 70 feet the combined drilling load gradually decreases down to 685 tons. But keep in mind that these 685 tons are available in the outermost corners of the drilling envelope, and that the load of 685 tons at 70 feet is significantly higher than what comparable rigs can achieve in the center of their drilling envelope at 45-foot reach. The cantilever pipe deck can accommodate up to 500 ton of tubulars. The high tubular capacity enables the rig to lift tubulars directly from the supply boat and place them on the cantilever. Bypassing the main deck pipe racks reduces the crane lifts and enhances safety when transporting tubulars. The rig is equipped with a dual pipe handling facility that makes it possible to make up and break out drill pipe, bottom hole assemblies, casing, tubing, and liners offline. This will significantly reduce time on the critical path. The rig utilizes fully mechanized pipe handling equipment. All pipe handling equipment is run from the ergonomically designed driller's cabin by the driller and the assistant driller. Great emphasis has been put into optimizing tripping and stand building speeds. As shown, the rig is capable of making up a treble of 13 3/8 inch casing and racking it back in the derrick while drilling ahead. The knuckle boom crane picks up all tubular sizes from 2 7/8 inch to 20 inch from the cantilever pipe deck and places them onto the tubular feeding machine for further transportation to the rig floor. When the tubular reaches the rig floor, it is picked up from horizontal and presented vertically to one of the 2 foxholes by the eagle arm placed just inside the derrick structure. A foxhole is a mouse hole with an inside elevation device able to raise and lower tubulars up to 13.6 tons. When each foxhole is loaded with 1 joint of casing, a 3rd joint is picked up and a double is made up by the torque master. The torque master is an iron roughneck that works like a casing tong. It handles all tubulars such as drill pipe, drill collars, casing, tubing and liners with diameters from 2 7/8 inch to 20 inch. The torque master has built-in torque turn capability, thus eliminating the need for special casing tongs. By choosing the torque master, we avoid having to change tongs when shifting between drill pipe and casing mode, thus enhancing speed and safety. The double is transported to the second foxhole and a treble of casing is made up. With the eagle arm working as a guide, the foxhole elevates the treble high enough for the pipe handling system to be engaged. The bridge crane, together with the lower guiding arm, picks up the treble and racks it back in the casing setback area. The setback area will accommodate up to 13,500 feet of casing, racked in trebles, and 30,000 feet of drill pipe in quads at the same time. The hydraulic roughneck is positioned after the rig floor to service the well center, making up and breaking out the pipe as required for drilling and tripping. The torque master continues to work offline at the mouse holes, where it can make up stands of casing, drill pipe and bottom hole assemblies, or lay out stands of drill pipe and bottom hole assemblies. As mentioned earlier, the cantilever is one big box, and the BOP is placed inside this cantilever box. This allows the crew to work on the BOP in an enclosed area, protected from adverse weather. The rig is equipped with a 15,000 psi 18 3/4 inch single stack BOP, consisting of 2 double rams and one 10,000 psi annular. By utilizing a single BOP system, the BOP hoses can be connected at all times. The BOP can be tested on the stump, leaving only one test to be carried out when installed on the high-pressure riser. The handling of the BOP is done via a carrier system, similar to the systems used on most semi-submersibles. As shown in this animation, the BOP is lifted from the combined test storage stump and placed on the high-pressure riser. The tensioning system will take over the load and the carrier can be removed. This system eliminates the need for overhead cranes and provides for safe and fast handling of the BOP. With simultaneous operations being an integral part of high-efficient drilling operations, the design incorporates a system of 2 hatches through the cantilever. The lower of the 2 hatches allows for Christmas trees, wireline BOPs, lubricators, risers, etc. to be lowered down onto the wellhead platform and installed offline. This enables the operator to run wireline and offline activities on adjacent wells while drilling ahead through the rotary table. The overhead XY crane can present equipment in either the well center or, as shown in this sequence, lower the Christmas tree through the lower hatch and install it on the platform wellhead. The mud return system is placed as close as possible to the diverter. By having the mud return system placed inside the cantilever box, the whole system can be hard-piped, leaving no connections or disconnections when skidding the cantilever. The mud return system has space for 1 gumbo shaker and comprises of 4 high-performance shakers, with space for an additional 2 units if needed. Space for additional solids control equipment is allocated, and the equipment can be installed on request of the operator. A heavy tool store has been placed inside the cantilever. This has been done to minimize the use of the main deck cranes in daily operation. Tools needed on the rig floor can be placed on the landing outside the storeroom for subsequent transfer to the rig floor by the knuckle boom crane. The knuckle boom crane is operated by the drill crew, and it is capable of lifting and transporting items of drilling equipment up to a weight of 6 tons. By utilizing this as a crane, it reduces the need of the rig's deck cranes, thus improving optimization and efficiency when planning ahead and not being sole reliant on the crane operator and deck crew. If we peel off one more layer of the cantilever, we can see the mud return tank with the degassers installed. The cuttings handling system, shown here with two large screw conveyors, transports the cuttings from the shakers. The system collects cuttings and loads them into skips or big bags for subsequent transfer to shore by supply boat. The rig is also prepared for installation of a cutting slurification and re-injection system. The available deck space has been greatly optimized by routing all ventilation hoods, exhausts, tank vents, etc. below deck to the aft jacking houses. The rigs are equipped with two main cranes of 80 tons static and 40 tons dynamic lifting capacity. This lifting capacity will enable the rigs to take on board heavy equipment, including the heaviest coil tubing reels from the supply boat. This provides for a clean, obstruction-free main deck that will be serviced by a forklift to minimize crane use and enhance safety. The variable deck load is 4,500 ton. The large deck space and deck load gives the operators an opportunity to optimize logistics in areas where supply boats are hard to come by. Let me take you below the main deck to show you a few enhanced features of the rig. The rig is equipped with two separate engine rooms. During normal operation, the rig will be able to run on one engine room, leaving the other room noise-free when performing overhauls and general maintenance. The rig is equipped with three 7,500 psi AC-driven mud pumps. The rig is equipped with an automated mud mixing system. No manual handling of sacks, etc. is required. The forklift operations area below deck has been expanded to incorporate the mud pump room and the lower store area. Another feature of this rig design is the access and escape route system below deck. In case of a general alarm, the exit from all rooms in the hull will lead into the main ring hallway highlighted here. Once situated in this hallway, you can go either left or right. No matter what way you choose, you will always end up in the safe area in the accommodation. The accommodation is divided into two blocks and wrapped around the forward leg. This design contributes to the large deck space. The port block is a quiet area with cabins only. The starboard block holds all offices, recreational facilities, and the galley. The accommodation is designed for 120 people. The design and development of these unique units from concept to reality is a combination of almost 40 years offshore experience, building of 18 other jackups, input from more than 30 operators, and implementation of more than 500 suggestions made by Maersk Drilling's crew from the existing fleet. Thank you for allowing me to present Maersk Drilling's high-efficiency jackup rigs.